Hello, hello, hello. Hopefully everyone can see me and hear me okay. Welcome to our GCSE Acids and Bases web class. Hopefully you guys can see me, you can see my screen, you should be able to see our slides. If you're here, please feel free to say hi in the chat. It'd be nice to see people who haven't, it feels like ages since we last had a GCSE chemistry YouTube class. So hello to those of you that are coming back again. Hello to those of you that are new, welcome. So this is going to be a GCSE chemistry web class on acids and bases. Yeah, please feel free to say hi in the chat. Nice to know who's here, but welcome. Hello, hi Zainab, nice to see you. This is, feels like we've been doing GCSE chemistry YouTube classes for ages now, but this is a web class on acids and bases. It's quite a fundamental bit of chemistry, working out what on earth's going on with acids and bases. So hopefully, yeah, it'll be a good YouTube class with lots of information in it. Hello, Alvina. Hi, Wala. Apologies if I've said your name wrong. Please feel free to correct me in the chat. But hello, welcome, guys. Nice to have you here. Oh, hi, Leah Kay. Nice to have you guys, you here as well. Welcome, everybody. So if you're new to our GCSE classes, then welcome. If you are an old hat and you've been coming for months and months, then welcome back. Hi Paco, hello Abdul as well. Nice to see you guys here. We're just going to give it another 30 seconds in case anyone is still waiting to join us, and then we're going to get started. So this is our YouTube class on acids and bases. Like I say, some real fundamental chemistry that we're going to be going through here. It feels quite abstract. It's probably the first time you've heard about some of this stuff, but it's really, really useful. And I think, like for me anyway, incredibly interesting, because it tells you a lot about how chemicals behave and why they behave like that. So hopefully we're going to get some good chemistry knowledge in here. Hi to Mihaela, nice to have you, and Tanisha and Lahai. Hello, everybody. Nice to have people waiting in the chat. Right, I reckon it's probably time to get started. If at any point you have any questions, oh, hello. Hi, Lek. Apologies if I pronounced your name wrong. Hi, Amy, nice to have you back again. Apologies if I pronounced your name wrong. But welcome, nice to have you all here. So this is our GCSE chemistry web class on acids and bases. And hi Mary as well. Feel free to ask any questions you have in the chat, and feel free to answer each other's questions. I'm going to try and get as much information from you guys as possible. So if you think you know an answer, please give it to me in the chat. Even if somebody's given another answer, if you think it's the same, you can say the same. If you think something different, then please feel free to say something different as well. And any questions you have, I will do my best to answer them. Hi, Emmanuel. If you think that I might have ignored your chat, feel free to send it again, because they do disappear off my screen quite quickly. So please feel free to send the same question again, and I will do my best to answer it. Hi Zara, nice to have you here back as well. Yeah, you can come back on the website if you fancy it. Right, so a little bit about me first. I'm Alyssa. I am the lead GCSE chemistry teacher at Snap Provise. I also teach A-level chemistry for Snap Provise as well. I have a PGC in chemistry education from Oxford, and I've been teaching A-level chemistry for the last 6 years, coming up to more now, because obviously time flies. But I love science. Chemistry is my favourite, but all the sciences are amazing in my opinion. So for the next kind of 50 minutes or so, we are going to have to cut it a little bit short so that I can start up the A-level class. But for the next 50 minutes or so, we're going to be hopefully understanding the difference between an acid and a base. Hopefully these are terms you've heard before. We're going to understand the definitions of a strong base or acid, a weak base or acid or base, got confused there, acid or base, a concentrated acid or base, and dilute acid or base. And we're going to understand how the pH scale works. So what is it? Hopefully something comes to mind when you think of the pH scale, but what is it? How does it work? Where does it come from? We're not going to look specifically at neutralization reactions, although we will brush over them a little bit. and we're not going to look at titration curves either, but hopefully we're going to get lots of your questions answered, and we're going to get lots of the information that you need in front of you. So these are the specifications for AQA, Edexcel, and OCR. This is basically a list of everything you need to know for your exams. If you haven't got yours, I 100% recommend downloading it because they're so, so useful. They're basically a checklist of everything your exam board wants you to know for your exam. So this is the stuff on the lesson that we're doing today that AQA wants you to know. It's not everything you need to know, obviously. This is just for the lesson we're doing today. This is for OCR, and so is this. And then this is Edexcel, and so is this. So that's what the different exam boards want you to know. If you haven't already, please feel free to download the slides, which is where this is. It's in the slides. It's in the link below. There should be a link to the slides below. So please feel free to download those. Then you can keep it for revision to use later on, or you can fill it in now, etc. So what do we already know? What do we remember from Key Stage 3? Because hopefully you would have done most of this at Key Stage 3. What do we remember? What do we therefore need to know for GCSE? So something that we learn at Key Stage 3 is a general equation for metal plus acid. What is made when you combine a metal and an acid together? Oh, Zara. Well, we miss you as well. Does anybody know, what do we make when you mix a metal and an acid? When a metal and an acid react together, what is formed? Metal plus acid makes, anybody know? If I were to drip a little bit of acid on a piece of metal, oh, we've got all of the bits we need, but not possibly in the right order. So metal plus acid makes a metal salt and hydrogen. Metal, salt, and hydrogen. So hydrogen gas is given off. Usually you'll see it bubbling. You'll see the gas being given off as effervescence or bubbling, bubbles, fizzing, etc. And you also form a metal salt. Why the concept of acid and base was introduced? I think in order to be able to classify materials, to be able to classify chemicals into different categories, so that we know approximately how they'll behave. That's probably why it was introduced. Zara, I don't know, I'm afraid. I haven't been told that it's likely to. So at the moment, no. As soon as we find out, hopefully we'll let you guys know. But at the moment, it's not coming back anytime soon, which is rubbish, I know. Apologies. Okay, what's the chemical formula for hydrochloric acid, and what's the chemical formula for sulfuric acid? Does anyone know? What's the chemical formula of hydrochloric acid, and what's the chemical formula of sulfuric acid? These you do have to know for GCSE. We do have to know these off by heart. Fantastic. It looks like everyone is nailing HCl. So capital H, capital C, small l. Yeah, we have to have a small l there, not a capital, because that means that the little l belongs to the C. So Cl is our formula for chlorine, our symbol, chemical symbol for chlorine, Cl. Good, so HCl for chlorine and H2SO4, good. H2SO4 for sulfuric acid. So if we have a metal plus an acid and our acid is hydrochloric acid, what's the name of the metal salt that is formed? Does anyone know? It's called a metal something. Metal something. HCl, if we add HCl to a metal, what's the salt? It will be our metal and hydrogen that's formed. Oh, good, well done, exactly right, a metal chloride, good. A metal chloride is formed, and again, we do need to know this. So if you add hydrochloric acid to a metal, you're going to form a metal chloride, whatever your metal was, chloride and hydrogen gas, fabulous. For the sulfuric acid, what is formed when you add sulfuric acid to a metal, you form a metal, what? Following on in the same sort of pattern that we just have. It's close. Okay, we've got a mixture of answers. It's a sulfate. What does the 8 bit tell us? Why have we called it a sulfate and not a sulfide? We have called it a chloride, but why are we calling it a sulfate? What does the 8 bit mean? Hydroxide is the name of an ion. Hydroxide is the name of an ion, OH minus, which we will mention later on in the class, definitely. So good. So well done, Joanne. Exactly right. And Mahela as well. Fantastic. It contains oxygen. I'm Maya. Well done. So the sulfate bit is because of this SO4. It's got oxygens in it, and we need to tell other chemists that it's got oxygens in it. So the sulfate means that there's sulfur, the S, and oxygen. 8 means that there's oxygen. Chloride means it's just chlorine. Chloride is just chlorine on its own that's added. Good, well done. Okay, let's keep going. So bearing all of this in mind, let's have a look then at our acids and our alkalis, or acids and bases. Good, well done, Demetria. It is a 2- ion. Good, and that's also very good to know as well. The sulfate ion is 2-. So definition of an acid. So at key stage 3, we think about an acid as something that reacts with a base to form a salt and water, or salt and hydrogen if we're adding it to just a metal. What is an acid though? What is the particle, the key particle that belongs in an acid that all of our acids have present? What is it? Do we know? Hi, Kian. Welcome. Nice to have you here. And hello to those. I can see some names I haven't said hello to. So hello to all of you guys. Sorry, I haven't said hi to you, but hello. So it's a species, a thing, something, a species. Good, that has hydrogen. Well done, those of you that said that. A species that produces a hydrogen ion, or releases, we could say, rather than produces, releases a hydrogen ion, i.e. H+, in solution. So hopefully, when we've done our work on ions, we know that hydrogen forms a H+ ion. I am going to put releases there actually, because that's a little bit neater. And we'll say aqueous solution. So hopefully those of you that have done acids, that have done ions, sorry, are aware that H+ is our hydrogen ion. It's when hydrogen has lost an electron. So it's just a proton, it's a single proton. So Ashley, it would be, what do you think? If it's a species that releases H+ into solution, is it going to be donating protons, or is it going to be accepting protons? You tell me. So strong acids, as somebody said as well, can dissociate in water fully. If it's a strong acid, we say that every particle of HCl, for example, which is a strong acid, completely separates. Yes, well done. Just because we could have a solution that involves a different solvent that's not water, so something like an ether, or so another chemical. Other chemicals can be solvents, other chemicals can dissolve things. Normally we think about water being like being a solvent, being the thing that dissolves stuff, but it can be other things. So just by specifying aqueous, I'm just saying that it is water this time. When I've put my acid in water, this is what happens. That's all that means. So strong acids ionize completely, or we can talk about it dissociating completely. Oops, complete, I can't spell. In aqueous solutions. So our HCl completely separates into H+ and Cl-. H+ aqueous because it's aqueous, it's dissolved. Cl aqueous because it's dissolved. Right, a couple of questions. Yes, good. So it is a donator. It donates. Acids donate protons. Yeah, good. Well done to those of you that said donating. Antonio, let me know if you're not happy with why we said aqueous solution, because I feel like I've already answered that. But if you're still unsure, just let me know. What do the ions bond to? Nothing necessarily. They're dissolved in water. So if we look at my diagram here, we've got our acid molecules, so our HCl, for example, that we put into solution. And when it is HCl, because it's a strong acid, each of those particles dissociates, it separates into its two ions. So what we haven't drawn in here is the water particles. So there will be water particles floating around as well. So we could draw them in if we wanted to. So there will be water particles in here, and they'll be interacting with the acid particles, but not bonding to as such. We kind of talk about them interacting. So that means here we've got our negative ion, which in HCl's case, in hydrochloric acid's case, is the chloride ion, Cl minus. So e.g. our Cl minus. Doesn't have to be though, could be something else if it's a different acid. And then we've got our positive particle, our H plus, floating around as well. So examples then of our acids, we need to know hydrochloric acid. We need to know sulfuric acid. And what's the other one that we need to know? Does anybody know? Hydrochloric acid. What's the other acid that we need to know, as well as, I'm going to spell it with an F, even though I don't like spelling it with an F. Hydrochloric acid, sulfuric acid, and what's the other one? Does anyone know? What's the other acid that we need to know? Oh, I might have frozen. It looks like my thingy has frozen. Oh, here we go. It might be coming back again. Am I back? Sorry, guys. Yes, well done, guys. It is nitric acid. Sorry, I think my thingy froze ever so slightly, so apologies if you lost me briefly there, but I'm back, so well done. Yeah, nitric acid, good. So nitric acid, for example, which is, oh, now my pen's being really slow. Nitric acid, HNO3. Nitric acid. If at any point you can't read my writing, by the way, please let me know. So can acid produce hydrogen ions in any other solution which doesn't possess water? Technically, yes, it could do, as long as the solution interacts with an acid in the same way. Then yes, good question. Water is a polar molecule, that's why it dissolves. Exactly right. Yep, water is polar, and so are our acids. They tend to be polar molecules as well. But that's A-level content that we don't need to know for GCSE. Good. Okay. So hopefully, I can't tell, my screen's telling me that the YouTube class is way behind, so hopefully everyone is caught up. Let's keep going. So we know that our two particles, we've got chloride and we've got H plus in solution. Don't worry about polar molecules, that's A-level content. I was just answering a question that someone had put in, so don't worry about polar molecules, but that's A-level content. Okay, so let's have a look at weak acids. So our weak acids, a strong acid completely dissociates. What's the difference with a weak acid? Still got to act as an acid. So what do we mean by a weak acid? Anyone know? Yes, so that is your definition of a polar molecule there. Good, well done, Kat. Fabulous. So it means that it only partially ionizes or partially dissociates. Good. Partially ionizes or dissociates in aqueous solution. Oh, can't spell aqueous solution. So for example, you don't have to know what this acid is, but it's ethanoic acid. Ethanoic acid still dissociates into its negative ion and its positive ion, the H plus, the acid part of our acid, still separates, but not every acid dissociates like that. Not every particle dissociates. So looking at our diagram, we can hopefully see that we've got some H pluses. So there's some H pluses floating around, but only a couple. Lots of the time, our particles stay together. So that's our negative ion. Okay, and the examples of this would be, like I've just said, ethanoic acid, which is CH3COOH. Citric acid, one you might recognize from our citrus fruits. Citric acid, which we don't have to know the formula for. You don't have to know the names of these, but just so that you're aware, there are a couple. And then something called carbonic acid. Again, you don't need to know, you don't need to be able to recall these, but it's just good to know that there are some out there. Right, questions. Good, it only partially ionizes in solution, so there are fewer hydrogen ions floating around. Yeah, exactly right. Yeah, good. Yeah, lots of organic acids are weak. Good point. Does dissociate mean the same as dissolve? Not quite, no. So we can have substances that dissolve in water that don't dissociate. So it's a very good question to ask, because things like our ethanoic acid, it still has to dissolve, but then it also partially dissociates. So dissolving just means breaking up into its individual acid particles in the water. So it stops being a solid, for example, most of the time it's a solid anyway, stops taking the form of a solid or being in the solid state, and it dissolves to be aqueous. It dissolves to be kind of mixed in and surrounded with your solvent, with whatever's dissolved it. Dissociate is the separation into its ions. So when hydrochloric acid, HCl, separates into the H and the Cl, and they move around separately in water. Okie dokie. Good question. There is, we have to make the assumption that strong acids completely dissociate, as in every particle dissociates, and weak acids only partially dissociate. So there is a very definite divider there between strong and weak. If it doesn't completely dissociate, it's not classed as a strong acid. Okay, hopefully that answers your question. Okay, let's keep going. So this, hopefully you guys again met at key stage 3, dilute and concentrated. How do we define dilute something? How do we define dilute acid, for example, or a dilute solution? What does this term dilute mean compared to concentrated? What's the difference? What are we comparing? Good question, Kat. You can probably answer that question yourself. We're going to look at pH later on in this web class. So have a think about what you think the answer to that question is. It's a very good question. So what's the difference then between dilute and concentrated? Good. So I like to think about, whenever I'm trying to consider which is which, I always think about squash, because squash, we think about having concentrated squash or dilute squash. So if it's really dilute, that means there's not many squash particles, but lots of water. And if it's really concentrated, it's lots of squash and not very much water. So it's the same between the two when we're looking at squash or when we're looking at acids. So a dilute acid, we would say, has a small amount of solute per unit volume of solution. So basically that means we have a low concentration of our acid in our solution. That's concentration. So that would mean small number of acid particles. Oh, that's supposed to say unit as well. So small number of acid particles, lots of water is a dilute acid. It's a small amount of solute, i.e. our acid. Solute is the thing that's dissolved. That's what a solute is. It's a thing that's dissolved. So a small amount of solute per unit volume of solution. And concentrated is the opposite. It's a large amount of solute, i.e. our acid, the thing that's dissolved per unit volume of solution, i.e. high concentration. So one thing that is quite hard to get your head around at GCSE is this difference between something being strong acid and weak acid and something being dilute acid and concentrate acid, because all four talk differently about the number of acid particles, but also about the number of actual particles per solvent. Right, sorry. I've had loads of questions that I haven't seen. So what does a solute mean? Solute is the dissolved thing. Yep. Per unit volume. So that would be, for example, if we have 3 grams of hydrochloric acid per centimeter cubed or per milliliter or whatever it is that we're measuring our volume in. So it might be 3 grams of hydrochloric acid per centimeter cubed compared to 0.3 grams of hydrochloric acid per centimeter cubed. That's what I'm talking about when I say per unit volume. It's per centimeter cubed or per milliliter, per whatever. So yeah, if anybody has any other questions I haven't answered, feel free to pop them in the chat again, because I can't, some of them have disappeared off my screen. Okay, so we'll have a think in a minute when we do our exam question about how we can compare the differences between dilute, concentrated, strong, and weak. What we're going to look at now then is this other term, an alkali. Alkali versus a base. What's a definition of an alkali? Anybody know? Similar to our definition of an acid. So an acid was a species that produces H+ ions in aqueous solution. So any ideas what the alkali bit means? What are we producing in solution for an alkali? So concentration is a term that we need to be used to, we need to get used to at GCSE. The concentration of something means how many things per unit volume. That's the definition of concentration. So concentration of people in a playground is how many people there are per, for example, meter squared in the playground. The concentration of apples on a tree is how many apples there are per meter cubed on the tree, or whatever it is. That's what concentration means. Yeah, well done, Rhea. Oh, good. Well done for your definition there of the difference between alkalis and bases. Yeah, good. Well done. Those of you that have said it's a species that produces OH- in aqueous solution. So it is a species that produces or releases OH- or hydroxide. Hydroxide ions. Actually, I'm going to put that over here so it makes more sense. Whoops. In aqueous solution. So for example, again, when we spoke about hydrochloric acid dissociating or separating into H+ and Cl-, the same thing happens with sodium hydroxide, which is an alkali. It separates into the sodium ion and the hydroxide ion. Both aqueous because they've dissolved in solution, they are in solution. Good. And then an alkali is a type of base, and as you guys have said already in the chat, a base dissolved in water is an alkali. An alkali that is soluble, that can dissolve, is a A base that can dissolve is an alkali. So an oh dear, can't spell. Alkali is a soluble base. So not all bases are alkalis, but all alkalis are bases. So base talks about its relationship with an acid. An acid and a base combine together to make salt and water. So if it can combine with an acid to make salt and water, it's a base. If it can dissolve in water, then it's also known, or you can call it, an alkali. So as somebody said, all alkalis are bases, but not all bases are alkali. So some bases can't dissolve in water, so we can't call them an alkali, they're just a base. It's a bit like, it's another way of describing things. It's like a kind of a step up, actually, in describing things. A base that can dissolve in water is an alkali. Good. Okay, let me know then briefly, give me a number 1, 2, 3, or smiley face, medium face, terrified face, on how you're finding that content. How confident are you feeling about that content? Just let me know in the chat. Give me a 1, 2, or a 3, and then we're going to have a go at super quick. Have a go at doing some exam questions before, some exam questions before going on to our part 2. Fabulous. It's absolutely fine to be a 3, obviously. It just gives me an idea of how we're feeling and where we're at in terms of our understanding. Awesome. Lovely, guys. Fabulous. Okay, let's keep going then. So let's have a go at some exam questions. So what is the ion present in aqueous solutions of all acids? What is the ion present in aqueous solutions of all acids? Can you name it for me? Good, well done, fantastic. It is H+, or you can say the hydrogen ion. That's absolutely fine. However, if you say proton, despite the fact that we do call it a proton, it wouldn't be accepted because they've asked for the ion. So they want the name of the ion, not our kind of colloquial slang name for it, which is a proton. So really well done to those of you that said H+, that's fantastic. That will give us a mark. Lovely. Then it says, give the name and formula of the ion present in aqueous solutions of all alkalis. So what is the name and formula, 2 marks here, name and formula of the ion present in aqueous solutions of all alkalis? So if it's an alkali, what is it? What's it got in it? And what do we call that thing? Very nice. Well done. The hydroxide ion. And we also have to say OH minus. It doesn't matter if you put the minus on the other side. It doesn't matter if you say HO minus as well. That is also fine. We tend to call it OH minus at GCSE anyway. So it doesn't matter which way around you put it. They're all fine, all accepted. Fantastic. Okay, so 1 for saying hydroxide ion, 1 for giving the formula. Then it says, a dilute solution of hydrochloric acid is considered a strong acid. Justify how an acid can be described as both strong and dilute. So how can an acid be described as both strong and dilute? One of the things that you get used to once you've done lots of exam questions is understanding what the exam question is asking. This exam question is basically asking us for the definition of strong acid and a definition of dilute acid. That's what it wants, 1 mark each. So justify how an acid can be described as both strong and dilute. Well, if we give the definition of strong and we give the definition of dilute, then we're justifying how it can be both, because we're going to give 2 different definitions. So what are those definitions? What's the definition of a strong acid and what's the definition of a dilute acid? What do we think? How do we what's the key point about strong? Oh, lovely. Hopsis. Hopefully that's how you pronounce your YouTube name. That looks fantastic. Yeah, really nice Lahey as well. That sounds great. Good. So we can talk about both how one, it completely dissociates or it completely ionizes. You can use either word. So a strong, it is a strong acid as it completely dissociates or completely ionizes, whichever you want to say. Oh, dearie me, what was that word? That wasn't a word at all. Dissociates. But it is dilute because, as you guys said, there's only a few acid particles per unit volume. Because there are only, so there is only a small amount of acid, only a small amount or a few acid particles, whichever you'd like to say, of acid per unit volume. So in both cases, we've given the definition of the word they've asked about, and that gives us our 2 marks. It completely dissociates in aqueous solution, but it's dilute because there's only a small amount of acid. I should put in solution there, but I didn't, sorry. So I should say in solution. And that gives us our 2 marks. Cool, anybody not happy? Anybody got any questions? Otherwise, we will keep going. So the next bit we need to think about, and I'm going to try and speed up a little bit because I don't want us to run out of time. If we don't have time to do the exam questions, which we might not, then you guys will just have to have a go at those yourself. So we're going to have a look at pH. What is pH and how does it relate to all this stuff that we've been looking at today? So what is pH a measure of? At GCSE, what do we think about pH being a measure of? What does the pH scale look at? What do we use it to work out? Anyone want to have a go? What is the pH scale and what does it measure? And do we know what the range is? What's the range for the pH scale? Nice. Fantastic. Yeah, it's a measure of how acid or alkaline, or the acidity or alkalinity of a substance. Fantastic. So it's a measure of the acidity or alkalinity of a solution. And we talk about it being from 1 to 14. We can actually have a pH of less than 1. So it is actually from 0 to 14. But you wouldn't necessarily lose a mark if you didn't say 0. We don't often think about anything as having a pH of less than 1 because that's an awfully strong acid or a very, very highly concentrated acid, but could be possible. So a very acidic solution will therefore have a pH of 0. I mean, it's very unlikely to ever have a pH of 0 because I think that would mean it's just H+ ions. Then a very alkaline solution, as you guys have noted, goes all the way up to 14. And then neutral, as again, I think people have mentioned as well, is 7. It's in the middle. Yeah, well done, guys. Yeah, fantastic, lovely, well done. Okay, so if we have a look at this then, what does it look like? Hopefully this is what we recognize. We recognize the pH scale as being that lovely rainbow of colors. We've got our neutral solution in the middle. And then we've got which colors are acidic and which colors are alkaline, which is which. Which is which. Yeah, good, Demisha. You're right. We can talk about them being the lower numbers being strong acids, middle being weaker acids, etc. Yeah. Good. So our red is our strong acid. Then we can have our weak acids. Then we can have our weak alkalis and our strong alkalis. Good. And what do we measure pH using? So we talk about the pH scale, but what's the name of the substance that we use to look at the pH scale? Do we know? Well done, guys. Lots of really good answers there. Well, what's the name of the substance, the chemical that we put in, that we use to look at the pH scale and measure our pH? Good question, Penelope. So we looked at that briefly. All alkalis are bases because all alkalis will react with an acid to produce a salt and water, but not all bases will dissolve in water. So if a base will dissolve in water, we can call it an alkali. You can also call it a base if you want, but only if it dissolves in water can you call it an alkali. So all of these are alkalis when we talk about acids and alkalis, because we talk about solutions, things that are dissolved in water, and only alkalis dissolve in water. Good, well done, guys. So universal indicator is the thing that hopefully you guys will have looked at as our substance that we use to look at the pH scale, and we look at what color it turns, we compare it to the pH scale, and hopefully that gives us a good idea of how acidic or alkaline our solution is. Very nice. Indicator, that's supposed to say, not indication. Indicator. And it measures our approximate pH, because of course, sometimes people, look at things and look at colors in different ways. And it might depend, on the temperature of the room or how much universal indicator you put in. We can use litmus paper, good. We can use other indicators as well, but if we're using the pH scale, then we'll probably need to use universal indicator or universal indicator paper. Yeah, well done, good. There are other indicators, which I've seen someone has just mentioned as well. So we can measure pH using other indicators as well. So methyl orange is an indicator. Methyl orange, litmus paper. Someone has also mentioned we can measure that. Does litmus paper turn in acid and alkali? What color does methyl orange turn in acid and alkali? And what about phenolphthalein? Yes, Rhea, exactly right. Yeah, exactly right. Yeah. That's kind of heading towards the A-level definition, because at A-level we look at specifically how much hydrogen there is present. And in alkaline solutions, there's very little hydrogen present, which is why they have a very high pH. Or in acids, they have lots of hydrogen, and so they have a very low pH. But at GCSE, we only really need to consider it in terms of H plus and OH minus. So that's really good. Okay, so what colors do they turn? So litmus paper is very much like the pH scale. The acids, litmus paper will turn red, and alkalis, litmus paper turns blue. So they're very much the same as our pH. Phenolphthalein, which is such a cool indicator, I think, it's colorless and pink, and it's the opposite. So pink I think of as being close to red, but it turns pink in alkali. So it's the opposite to what we would consider litmus paper, one of our more normal indicators, to be, and it's colorless in acid. And that's quite a fun one to have a go at doing some experiments with. And then methyl orange doesn't actually ever really turn orange. It's either red or yellow. I think methyl orange because when it's turning, it kind of goes a little bit orange, but it's the same as acid in that it same as our litmus paper and pH scale, in that it goes red in acid and then yellow the other one in alkali. Why? So because that's the way it's made. It's made so that it is that color in an acidic solution. So the acid forces it to be that color. Yeah, good question. And yet phenolphthalein does go pink in alkalis, and methyl orange is pink or red, yep, in our acid. So the other thing we've got a picture of down the bottom here that we can use to measure pH, and we can be a little bit more exact with it, is this thing down here. What do we call this thing down here that we stick into acid solutions or alkali solutions to measure the pH? What, anyone know what we call that? So other indicators, our litmus paper, our methyl orange phenolphthalein, they can only measure approximate pH again. But this thing down the bottom can measure exact, as long as we calibrate it properly, as long as it's set up properly. It's a pH probe, well done. And that can measure exact pH. Because it's linked up to a machine that can tell us the exact pH of a solution. So we can measure approximate pH quite easily, and that's still really, really useful in chemistry. Or we can use a pH probe to measure exact pH if needed, if necessary. Okay, final kind of thing that we need to look at then, and hopefully we'll still have time for our exam questions, or at least one of them, is pH and H+ concentration. So this is what I've had a couple of people mentioning briefly in the chat. So pH, the H bit, comes from hydrogen. So what we're looking at is how much hydrogen there is in a solution. And H+ concentration is, it kind of goes, it feels like it goes opposite to pH. The more H+ you've got, the more hydrogen ions you've got floating around in solution. So if you've got a stronger acid, for example, where it's all dissociated, or you've got a more concentrated acid where there's lots and lots of acid particles that are dissociated, then the pH is really low. And it's all to do with the maths behind it, which you don't need to know at GCSE, but you learn about at A level. It's all to do with the maths. So if you've got lots of H+, you have a really low pH, really small number. And if you've not got very many H+, you've got a really big number, a big pH. So R14, pH 14 or higher. So that means as pH decreases by 1 unit, so as we go from pH 3 to pH 2, for example, the H+ concentration is actually changing by a factor of 10. So it changes by increasing, because we're getting more acidic. So increasing by a factor of 10. So as we go from pH 3 to pH 2, we actually get 10 times more H+ in solution. So if I have an acid that's pH 3 and I have another acid that's pH 2, the pH 2 will have 10 times more hydrogen ions floating around in the acid than the pH 3. So if every time you go by 1 pH, it changes by 10 times, if you go by 2, so go from pH 3 to pH 2 and then to pH 1, it actually changes by 100. So again, if I've got a solution of pH 3 and I compare it to a solution of pH 1, my pH 1 solution will have 100 times more acid particles per unit volume than my pH 3. So it'll have 100 times more acid particles than my pH 3. So it's not what we might call a linear change. It's much bigger than that. Every step down the scale is times by 10. So if you go from pH 14 to pH 1, then you've gone 14 steps. So that's 10 with whatever it is, 13 units in it, 13 zeros on it. Lots and lots, very big. It is logarithmic, yeah, but that again, that's A level, so we don't have to worry about that. But yes, it is a logarithmic scale. All we need to be aware of is that the concentration of H+ changes by 10. Obviously, if we go from pH 1 to pH 3, it decreases by 10. Or if we go from pH 7 to pH 8, decreases by times 10. That's the key point for GCSE. So final thing then is looking at this concentration of H+ and comparing our pHs. Think about if we've got a solution. So I've got a solution and I add an acid to it. Then because I'm adding an acid, that must mean I'm adding H+, because because I'm adding an acid and acids have H pluses in them. So that means in my solution, if I'm adding acids, the number of H pluses in my solution is going to increase. If it increases, what happens to the pH? If the concentration of my H pluses is increasing, what's happened to the pH? Is it going to increase as well, or is it going to decrease? Does it get, if I'm increasing the H pluses, which way does my pH number go? Does it increase or does it decrease? Good. It decreases. So well done, those of you that are saying decreases. So it gets more acidic. It goes lower. The pH gets lower as it gets more acidic. Well done. And the same thing then, or think about it again, if I have a solution, but this time I add an alkali, so my concentration of OH minus is going to increase. What's happening to my pH? Is my pH going to decrease or is my pH going to increase? I'm adding OH minuses. So is my pH going to increase or is my pH going to decrease? Is it getting more acidic? Is it getting more alkaline? Which way is it going? Good, well done. My pH will increase because it's becoming more alkaline. And we need to be able to talk about the change in pH when you add an acid or when you add an alkali in our exams. And we also need to be able to say in a neutral solution, when you've got a neutral solution, it's not more acidic or more alkaline, it's neutral. The concentration of our H pluses is equal to the concentration of our OH minus. So at a neutral solution, the concentration of H plus is equal to the concentration of OH minus. Cool, fantastic, well done guys. Lovely, really, really good. Okay, I'm going to need to disappear in a second. Otherwise I'm not going to be able to get A-level done up and running in time. So apologies, we haven't managed to have a go through any of these exam questions, but please feel free to have a go yourself, see if you can have a go at them. How is everyone feeling about the pH movement and things? Fair enough, that's absolutely fine, looks good. Fantastic. So hopefully this has been useful. Hopefully we have, oops, let's skip through those. So apologies, we're not going to get a chance to do those exam questions, but hopefully you are now feeling more confident and able to understand the difference between an acid and a base, or an acid and an alkali. And hopefully you know the difference between a base and an alkali, or how to differentiate between the two. We can understand the definitions of strong, weak, and then concentrated and dilute in relation to our acids. And we can understand how the pH scale works. Final thing from me, if you have any questions, please pop them in the chat. But otherwise, we've got some upcoming web classes. So if you fancy coming back next week, I think, is it next week? I don't know. Yeah, next week. Then we've got physics, GCSE physics, and then the week after biology. So get these in your, get them in your schedules, set a reminder, etc. And hopefully we'll see you in some future web classes. So, oh, thank you. So Connor, these are our web classes, upcoming web classes. If you have a look on our website, please feel free to go onto the YouTube class, the YouTube channel as well, because we've got all our old web classes that you feel free to look at, and you should still be able to access the slides and stuff. So, and we try to do a GCSE web class approximately every Sunday. So please feel free to come and join us. The YouTube live schedule has just been popped in the chat for you. And we will hopefully be, hopefully I'll see you very soon. If you have any questions, please send them to hello@snaprevise.co.uk, and hopefully we can answer your questions. But have a lovely rest of your Sunday, guys. I'm going to need to disappear so that I can set up for my A-level class. So have a wonderful time. We do A-level web classes, so we're going to be on hopefully in about 5 minutes doing an A-level web class as well. So hopefully see you guys soon. Any other questions, send it there. Thank you very much, guys. You've been wonderful. See you soon. Bye.